This year's BALTOPS experimentation is the largest that we've had in BALTOPS past, incorporating numerous DoD institutions and civilian institutions of people coming from across the United States and NAVUR to come together for their various objectives and testing out of their sensors to aid in MCM clearance objectives. So this year's BALTOPS MCM experimentation focuses on decreasing the detect to engage sequence for more efficient minefield clearance. So we're doing that via the use of unmanned surface systems, underwater systems, and air systems. Those systems are all using different types of sensors incorporated and conglomerated into one common tactical picture to allow units to real-time see the sensor footage for more efficient minefield clearance, going from detection of mine and mine-like contacts to its reacquisition, identification, and neutralization. For this year's BALTOPS MCM experimentation, we have three separate and distinct lines of effort. The first is the employment of 6 fleet unmanned underwater vehicles, the Mark 18 Mod 2s, as well as the REMUS 600 from the Office of Naval Research. Those unmanned underwater vehicles are embarked on the FGS Helmsen out of WTD-71, German Naval Maritime Experimentation Unit. What the UUVs are doing is collaborative autonomy to allow for more efficient minefield clearance.
The unmanned underwater vehicles that we have operating out here in Schoenhagen interact with the greater exercise of BALTOPS 2021. We were given a simulated minefield, and what we're doing here is sending in UUVs to the area to dynamically look at the bottom, determine if there are contacts, go and reacquire those contacts, and then send that data via Iridium back to the Command Operations Center centered in Putlos. That data is being pushed up to ATAC, giving everybody a better understanding of the threat area on a much more global scale. So we interact with the Marine Corps by the vehicle is generating acoustic communications back to our gateway buoys, which are stationed outside of the minefield. From there, the data is sent via Iridium up and over to our shoreside monitoring station, and that data is being pushed through the new software IS-2 Ops, which is being proofed out here, and then into ATAC. ATAC is that Marine Corps component for C2.
The second line of effort is for unmanned sensors employed here locally, MCM ashore at Putlos. That is with the coordination of ground vehicles, surface vehicles, and other unmanned underwater vehicles that are employed with their various sensor nodes to do bottom hunting and mapping for more efficient minefield contact localization.
So with the experimental equipment that we are using, the Marine Corps has never dealt with the underwater domain. We've done everything surface where the Catif and Cliff handed off. Now within GPC, there's a zone that's not a defined line. So we need to find something to do that, and it's unmanned systems. And unmanned systems that we are currently investigating using some program of record, we're working towards our vision, is that gap to take the man out of the minefield, so to speak. And if we can take the man out of the minefield and automate it and feed a common operating picture efficiently, it's going to, the collective is just going to be able to think faster. It's mosaic warfare. Specifically for BALTOPS, the continued integration with this and expanding upon that, especially in the underwater domain, is going to be critical for the future.
The third line of effort is for the incorporation of these various sensor nodes into one common tactical picture. That is done via the ATAC, Android Tactical Assault Kit, as well as the Information Systems to Operations, a project run by NRL for the compilation of the various sensor data into one readable common tactical picture that can be read by tactical units employed ashore here at Putlos, as well as the floor.